Okay, so I want to do a little warm-up problem, a couple of warm-up problems, let's see, with sequences. So I've got AK. The first sequence is going to be AK is equal to 3K over 1 plus 6K. Okay, and I don't know if a sort of big K analysis is completely necessary for this problem, but I'm going to do it just because I want to sort of get in the habit of doing this kind of big K analysis. So what's going to happen for big values of K, this is roughly going to be 3K over 6K. The K's cancel, and so this is just equal to 1/2. And so my intuition, whoops, not 1/3, I don't know what happened there. So my intuition then is going to be that the limit of this sequence is equal to 1/2, because for big K's, the terms AK looks a lot like 1/2. Okay, and there's two ways that I can do this. The first way, I want to compute the limit is the limit of AK as K goes to infinity. I've got 3K over 1 plus 6K. The first thing that I'm going to do, the first method, I'm just going to divide the top and bottom by K. So I'm going to get 3, and then in the bottom I'm going to have 1 over K plus 6. Okay, and because the function 3 over x plus 6 is continuous, as long as x plus 6 is not equal to 0, I can move the limit to there, and the limit of 1 over K is equal to 0. This is 3 over 6. This is equal to 1/2. Okay, and so that's one way to show that the limit is 1/2. The other way is to just treat this kind of as a continuous variable. This works whenever whenever like the sequence is if we think about putting in an x instead of a k, whenever that is a continuous function that we can do L'Hopital's rule on, then we can also do L'Hopital's rule on the sequence. Okay, and kind of maybe not using the best notation, but it's what we're going to use. We're going to take the derivative of the top and bottom with respect to k. So notice the top is going to infinity, the bottom is going to infinity. So this is a L'Hopitalable form. So I've got it's in an indeterminate form, infinity over infinity. So if I take the derivative of 3k with respect to k, I get 3. If I do the derivative of 1 plus 6k with respect to k, I get 6, 3 over 6. So the limit of 3 over 6 is just 3 over 6, and this is also known as 1/2. Okay, so that's one way to do this. Okay, so let's look at another sequence. So let's say that our sequence is something like cosine of k pi times k over k plus 1. Now, whenever we have a sequence where it's kind of alternating signs, like cosine k pi, I want to sort of break things apart, where you have one part that's just sort of carries the size information about the sequence. In other words, there is no sign, and then one part that has the sign. So I'm going to write this as cosine of k pi. Breaking this up is not always possible exactly how I said, but I do want to break it up into something that has like a sign and something that is positive. And so this is how I'm going to do in this case. Cosine of k pi, this is what changes signs. K over k plus 1, this does not change signs. And if I think about what's happening here, well, as k goes to infinity, you can show for yourself by either using L'Hopital's rule or dividing the top and bottom by k. This is going to go to 1. But notice cosine of k pi, this is going to alternate back and forth between minus 1 and plus 1. So what's going to happen is that some terms of the sequence are going to be going closer to 1. In particular, when k is even, the terms of the sequence are going to be getting closer to 1, and when the k is odd, the terms of the sequence are going to be getting closer to minus 1. So half of the terms are getting closer and closer to 1, and half of the terms are getting closer and closer to minus 1. So then there isn't one unique number that all of the terms of the sequence are getting to. Half of the terms are going to plus 1, half of the terms are going to minus 1, and so the limit does not exist. So the limit does not exist. Okay, so that's it for this video. Just wanted to do a couple of warm-up problems. I'll do some more challenging problems in upcoming videos.